So 12.2 is all about surface area of prisms and polyhedrons, okay? All the vocab is on the first page of 12.2, and you can read through all that. It also gives you formulas, but I'm not a big fan of formulas because nobody memorizes them, and it just makes more sense to understand how you get the number to me. So I'm going to walk you through how I do it. Feel free to use the formula if you want to. So example 1, I'm going to show you how I would do it, and then we'll go through the rest of the problems. Alright, so you're given this prism. Alright, so what you're doing for this is they've given you a triangle base, so the top and the bottom are the bases, and then the sides that connect the bases are called the lateral faces, so lateral sides. So they give you this triangle, and they've got these two dashes, which we all know means that they're congruent. Okay, so I like to draw the base like separately sometimes so I can see what I'm working with. So we've got this triangle up here that has 6 inches for a base, and since this is a marking that's the same, that means the height is 6 inches. Alright, so we've already talked about that in previous lessons, I think 9.4, about special right triangles. So if you've got an isosceles right triangle, so these two sides are the same, that means these angles are the same, which make them both 45. And we already know from special right triangles that when you're trying to figure out the hypotenuse for that, you just take this side, so this is your W, so 6, and then you multiply it by square root of 2. So it's just 6 square root of 2, okay? If you need a refresher on that, go back and look at my video on 9.4, and you'll see the lesson on special right triangles. So, you also do the Pythagorean Theorem, but that's the shortcut way. So, we know all the sides of the triangle. So now we need to figure out what the area is of the triangles, because we're trying to find the surface area. So we're trying to find what the area is on the outside of this 3D shape. So to find the area of the bases, we need to do the area of the triangle. So you're going to do 1/2 times the base of 6 times the height of 6. So 1/2 times 6 times 6 is 18, and it's in inches. That's our unit they gave us, and you would say squared to represent area. So that's the area of just one of the triangles. So we're going to have to remember to add that 2 times when we go to the later part of the problem. Alright, so now what I do, instead of doing a formula, I like to just figure out what the area of all the sides are and add them together. Okay, so if you look, it's just 3 rectangles that are all in different spots. So you have this rectangle here in the front, you got one here on the side, and you got one back here. Okay, so to find the area of the first rectangle, area of rectangles is just length times width. So they're all 8 inches tall. So you're going to do 8 times 6 for this first one, which is 48. The side one is also going to be 8 times 6, because this triangle's got 2 sides that are 6. Okay, so 6 times 8 is 48. And then this side back here is going to be 8 tall, but the width is the hypotenuse of your triangle, which was 6 square root of 2. So you do 6 square root of 2 times 8, which is 48 square root of 2. I would leave the square roots alone until you absolutely have to change them. So then to find the area of around the shape, we're going to add those 3 together. So do 48 plus 48 plus 48 square root of 2, and you get 163.88 inches squared. Alright, so now we're going to add the 2 bases. So remember, the base has an area of 18, but we have to add it twice because you need the top and the bottom. So you add those, and you get a total area of 199.89 inches squared. I would do at least 2 decimal places. It doesn't say specifically what to do in the directions, but I do at least 2. Alright, so that's how to do example 1. Alright, so they gave you a very similar problem for number 1, because you have triangle base again. So this time they gave you the measurements for the triangle down here. So what I would do is redraw your triangle. You've got a 4 and a 5. Now the problem is this is not the foundational right triangle. This is not a 3, 4, 5, okay? So we're going to have to figure out the hypotenuse by doing the Pythagorean Theorem. So you do 4 squared plus 5 squared equals x squared. So 4 squared is 16, 5 squared is 25, and then you have x squared. 16 and 25 make 41. 41 does not have a perfect square root, so I would leave it as square root of 41 for right now. So that's your hypotenuse of this triangle. Okay, if you need a refresher on Pythagorean Theorem, go back and check out the 9.6 video, the 9.3, I think, and maybe 9.2. Okay? So that takes care of your bases for like the sides. So now we have to find the area of the triangles. The area is just 1/2 times the base times the height, which is 10. Alright, so now we're going to find the area of all these rectangles. So this first rectangle has a width of 4 and a height of 14, so 4 times 14 is 56. This rectangle has a width of 5 and a height of 14, so 5 times 14 is 70. And the back rectangle over here would have a height of 14, but its width is the hypotenuse, which we found was square root of 41. So you're doing 14 times square root of 41, which I would write like this, and leave alone for right now. Then when you add them all together, and you can type that in your calculator, you get 215.64 meters squared. We're in meters for this problem. Alright, so now you have to add the top and the bottom, which we found were 10, so you add 10 2 times, and you get 235.64 meters squared for the surface area of this shape. Alright, so number 2, they changed it up and they gave you rectangles and squares. Okay, so to find the base area of a square, in case a square, or it's not a square, it's a rectangle because the two sides are different. So, but with squares and rectangles, you just multiply the length times the width. So you're going to do 7 times 8, which gives you 56. So that's the area of the top and the bottom. Then we just go around and do the rectangles. Now they're going to repeat. Okay, so on this one over here, you're going to have 12 times 7 and then 12 times 7 over here. And the front and the back, you're going to do 12 times 8. So that's why they show up twice. Okay, so when you multiply those out, 12 times 8 gives you 96. 12 times 7 is 84. It repeats. Add all 4 sides together, you get 360 feet squared. Then you're going to add the 2 bases, so the top and the bottom were 56. Add all that together, you get 472 feet squared. Okay, so that's how you find the surface area of all those problems.